Hello students! Today we are going to continue talking about hyperbolas. Eventually we're going to go a little bit deeper than we did in the part 1 video, but for now I just want to kind of review how you graph some hyperbolas and identify the important information. Now on your note sheet you should have the same information you discussed in day 1. I'm not going to go over it because you already watched a video on it, but if you still have questions after the video and in-class practice, please ask your teacher in class. So number 1 asks us to graph the equation and identify the foci and asymptotes. So remember, the first thing you need to look at when you're graphing hyperbolas is which direction is it going in. Okay, is it going in the horizontal or vertical direction? Since our x-coordinate is what's being subtracted, that means we're in this situation up here, and this is going to be graphed eventually in the vertical direction. Now, I don't know why that shrunk, but still same formula. Okay, so now that we know we're graphing the vertical direction, let's find our center, our foci, and our asymptotes. So starting with the center, we've been doing this since we started with circles. Our center comes from what's in the numerator here. Now the key I always think to remember is what lies inside lies to you. So even though this says -1, it's really a +1 for our x-coordinate. And since this is a +2, it's actually a -2 for our y-coordinate. Once we find our center, I always like to find my A and B so I can figure out my box, or how far are my points going to be from my center. So since your x-coordinate is what's being subtracted, remember that's your B this time. Okay, so B is actually the square root of your denominator, which is plus or minus 8. Okay, your A value is not necessarily the bigger number like it was in the ellipses. It's whatever the positive fraction is, which is this y1 this time. So our A is the square root of 36, since that's a squared, so it's plus or minus 6. So to kind of translate into the graph here, our center is at 1, -2. So here's 1, -2. And remember, our y is our vertical distance from the center. So we either have to go up 6 or down 6 to plot those 2 points. So 1, 2, 3, 4, 5, 6. Okay, here's 6 units away from the center. And we also want 6 units in the other direction. 1, 2, 3, 4, 5, 6. About here. Maybe it's not perfect. That's okay. And then our B direction is now our X direction. And we want to be 8 units from the center. Key, from the center specifically. 2, 3, 4. So this is 1 unit, 2, 3, 4, 5, 6, 7, and 8. Okay, and it's directly horizontal from the center. Same thing in the other direction. This is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we can create that box that tells us where our hyperbola should be. Okay, between all of our given vertices here. I will also draw the dotted line from each corner to figure out a better idea of where our hyperbola should lay. And that should go through the center of both of those. Okay, so now that I've drawn my red asymptotes here, I can just go ahead and draw in my hyperbola. And remember, it just kind of like grazes the asymptotes but doesn't actually cross them. Sorry, this is going into the next problem, but I made my graph extra big this time. Last step, as always, will be to graph the foci. Now keep in mind, for the hyperbola, our equation for foci is c squared equals a squared plus b squared, not subtraction like the ellipses. So we can plug in our a squared is 36, our b squared is 64, and 36 plus 64, remember, gives you 100. So c squared, or sorry, c then is plus or minus 10. And since we're going in the y direction, it's going to be 10 units from the center. Specifically 10 units up or down. So we count 1, 2, 3, 4, 5, 6 was our vertex. Then we would need to go 4 more. So 1, 2, 3, 4. Here would be 1 foci. And remember, this center is 6 units below the center, so we'd have to go 4 more for our second foci. Now, as far as writing what those points are, And whether it's the vertices or the foci, you're adding those to your y coordinates. So specifically, our foci, we'll write them off to the side here, will be 1, comma, -2 plus or minus 10. Okay, and you could just count these points on the coordinate plane, or you can add them up and you get 1, and -2 plus 10 gives us 8, and our other foci is 1, -2 minus 10 gives us -12, okay, which you see on the graph here as well. Our vertices, just to kind of have them written down, was 1 and -2 plus or minus 6. So 1 was 1, -2 plus 6 gives us 4, and 1 was 1, comma, sorry, so many ones, -2 minus 6 gives us -8. So those are the points we already plotted just by looking at the coordinate plane, but you can also write them as points so you have them as well. Again, this is all very similar to ellipses and circles. Just make sure you're identifying, what am I looking for in the given graph? Am I looking for vertices and co-vertices, or am I just looking for vertices and foci? Whatever it is, also keep in mind where it comes from. So in this case, if it's subtracting the x, we're vertical. If you're subtracting the y, it's horizontal. That's different than ellipses. Very similar equations. Notice the little differences though, and you'll be good to go for the test. Okay, so now the main new point of this video, don't mind me while I erase some of the information that was in the way. Our goal is really to write the equation of a hyperbola given our foci and vertices, so going backwards from drawing the graph. Let's start with problem A. So they give you foci are 0, 13 and 0, -13, and our vertices are 0, 5, 0, -5. Now first thing we need to figure out is this going to be a horizontal or vertical graph? So then we know which equation to plug our numbers into. Okay, and the way we can tell that is based on which axis our foci and vertices are on. So since our x stays the same for the foci and vertices, that means these are going to be vertical distance. Okay, if you plot these, our x value is staying the same, but we're going up 13 or down 13, so that's vertical. Which means we're going to use that second equation that we saw in example 1 as well. Or our x value, our x fraction is going to be the one that's subtracted. In order to actually fill in the equation for this particular hyperbola, we're going to need to figure out what the center is, our a squared is, and our b squared. And I always like to draw a picture before we actually fill out this information. Just kind of gives us an idea of what we should be doing. So this isn't going to be accurate, but our foci are somewhere up here, okay, at 0, 13 and 0, -13. So not moving on the x, but we're moving up and down on the y. And our vertices are at 0, 5 and 0, -5. Now this isn't perfect, but they are going to be somewhere around here. Looking at this picture, we can easily figure out what the center is. Keep in mind that the center is really the midpoint distance between our two vertices, okay, or our vertices are the same distance away from the center. Remember, you add or subtract the same number. Since they're just 5 and -5, we know that the midpoint of that has to be 0. Okay, they're both 5 units away from 0. Okay, so that means our center x-coordinate is 0 and our y-coordinate is 0. Nice and easy. If you weren't sure how I got that just by looking at the graph, you could always actually find the midpoint of the y-coordinates. Remember, we find the midpoint by adding them and dividing by 2, and it'll still give you a y-coordinate of 0. Something to think about. Okay, in order to find our a squared and b squared, we're going to need to use our foci equation, which is c squared equals a squared plus b squared. And we can fill in the information we know. Okay, so first thing we know is our foci are c units away from the center. In other words, you're adding or subtracting 13 units to our y value, which means our c value is 13. Okay, but c squared would be 13 squared. We also know that the vertices are a units away from the center. So since our vertices are both 5 units from the center, that means our a value is also 5, and a squared would be 5 squared. And what we don't know is b squared, but luckily we can solve for that. So just simplify that up, we get 169 is equal to 25 plus b squared. and that makes b squared 144 if you subtract 25. Now, you may want to solve for b because that's what we're used to, but keep in mind our end goal. We want to write our equation, and I'll scroll back up, to look something like this general form. And in this general form, you just want a squared and b squared. We don't want a and b in our equation, so we don't have to go any further. Okay, our b squared is just 144. Our a squared we plugged into our equation. It's 5 units away, that's our a, but our a squared is 25. Now that we have all this information, we can finally write the equation of the hyperbola. So, remember we're subtracting our x value since it's a vertical distance, and our center 0, 0, so there's nothing added or subtracted to our y. Our a value goes under our y, or sorry, our a squared, and our b squared goes under our x. And hyperbolas are always equal to 1, or we want them to be equal to 1 in standard form. So there you have it, the equation of a hyperbola. You figured it out on your own. Congrats. Now I see there's a part B here, and we do have time to do part B, but I actually want you to try this on your own. And that's because it's really important to test whether or not you understood the video. If you can do this on your own and bring it to class, you're in good shape. If you can't, I want you to re-watch part A, and if that still doesn't help, I want you to come tomorrow with questions. Make sure you write down those questions on your note sheet so you don't forget. But otherwise, try B and have a good night.